Hello everyone, I am Nitesh. Welcome back to my channel, the Learning SDB from can to cloud, build at home. So basically, in the last video, we have seen that we have a roadmap of 6 different phases where we will achieve this entire project. And in the phase one, we will talk about SDB basic because it's equally important because many of you uh, uh, basically requested like, okay, if you can talk from the scratch what exactly the software defined vehicle is, because they are either college going or they are new to the SDB, because they are working in automotive since last 4 5 years but they have not worked on SDB, so they want to know what exactly SDB. Yeah, so I'll talk about SDB basic first and then we'll stay forward to the second, third and so on. Yeah, so in day one we'll talk about what exactly software defined vehicle is. Yeah, so SDV. Yeah, so if it SDV stands for software defined vehicle. Why it is called software defined vehicle? Before before coming SDV, does car do not have software, or was it hardware defined? So, so to understand that, let let me explain you different vehicle architecture. Or before going to the vehicle architecture, I'll give you a simple example of day-to-day life you are using mobile phone. Yeah. So back then, if you have used Nokia 1100 in the early 2000 or 2000, basically, one or two, or might be before 2005. Okay. Yeah. So what exactly Nokia 1100 was bringing in? So this was the phone, and this phone has back then SMS feature. Then it has call log feature, and it has games feature, small games, right? Like snakes, or something was there, like snake game was there. Yeah. So imagine during the manufacturing, any of this application was missed by manufacturer. Imagine, will you be able to update this application once it is received to the end user? Answer is no, right? Remote. Basically, the question here is, will you be able to flash this applications remotely to the end users? Answer is no, right? Exactly. You cannot do that. But when you compare to the modern mobile phone like Android or iPhone, what it has, you buy any phone from the market. If there is a firmware update, you will get notification there is a new firmware is available. You just download it, install it, and reboot and start using it, right? Download it, install it, reboot, and start using it, right? And without going to service center, it is possible, right? Similarly, if you have any applications, now you are using WhatsApp, for example, everyone might be using WhatsApp. So WhatsApp has a new feature, for example, now it is available. It will basically, you can pull it, you can update it from Play Store, you can download and install, reinstall, and start using it, right? So remotely all these things are possible. Similar way, software defined vehicle, before software defined vehicle there are traditional vehicle, for example, the still these vehicles are we all are using, right? So imagine we have vehicle, right? And if the vehicle has multiple issues, right? Different CAN buses are there. These are the networks. They are different nodes. Basically, these are different nodes, different node. Yeah. What if any of these issues are, for example, having some issues? Okay. Will you be able to do troubleshoot? Obviously, if you have OBD tool, you can do it. But will you be able to do remote diagnostic of these issues? Answer is no. You cannot do remote diagnostic in traditional vehicles. But saying no is a correct word. It is not possible, or it is possible, but it is really complex. It is increasingly difficult, and realization is too tough. Answer is you can have remotely update on this traditional vehicle as well, but it is managing these many issues. Or I'll tell you, if I'll discuss about more into architecture side, I'll explain you how it is difficult, but it's really difficult. Yeah. So what exactly I mean to say is, or you have, for example, one of the application is missing over here, right? And if you wanted to update remotely, it is not, it is possible, but it is too complex, because if you see the distributed network architecture, you would have different CAN buses. Out of these CAN buses, there are n number of issues, and this n number of issues, if you have this OTA mechanism, you need to have for all these issues, and it's a huge effort is required. Also, complexity is too high. I'll discuss all these things in detail in just few minutes. So basically, as of now, you understand, in general practice, in distributed architecture or traditional vehicles, remote update, remote troubleshooting is not possible, right? It's possible, but it is really complex. So generally, it is OEMs avoid doing that. OEM does not do the practice, but starting of SDB happened from here itself. People OEM started having, for example, let me give you a hint also. For example, let me just let me delete this one, or maybe I'll go a bit here. Yeah. Imagine we have this vehicle architecture, for example, the distributed architecture. I'll I'll talk you later what is distributed architecture. Let's suppose this is vehicle architecture, traditional what we have, and there are n number of issues, right? N number of issues. So if you would have, you wanted to update any of this application, you should have OTA update for all these issues, because you don't know whether which controller have required remote update, right? So managing this many issues in traditional car, if you compare to what feature right now we have in the car, and if you wanted to use distributed architecture or traditional vehicle, you have more than 100 plus issues, and managing 100 plus issues will not be easy, right? For photo update, or basically remote update, remote troubleshooting, or if you wanted to roll back to the old applications, which was, you feel like, okay, later on which the last one was right, these all are increasingly complex. You should not do this with the distributed architecture. Yeah. So I am talking too much about distributed architecture, and you might be confusing this. What exactly this distributed architecture you are talking? I do not understand, right? And could you please give me some hint on it? So exactly. So for that, I have. So these are basically three different architecture OEMs generally follow. Yeah. So one is distributed ECU architecture, second is domain control, third is centralized zonal issues. Centralized zonal issues is the latest vehicle architecture, which heavily SDV rely on. Okay. Basically, SDV production grade HDV use centralized or zonal architecture only. They are not using these two. I'll explain you why this is. And somebody has rightly pointed out in our last video, Nitesh, you are showing the demonstration where you are updating, just you have a traditional architecture where you have one AEB issues, traffic sign memory, and you are remotely you're basically controlling the issues, or you remotely turning your light. Basically, will it be SDV architecture, right? So so basically, I want to highlight, yes, SDV, as I was already speaking since last 10-15 minutes, that SDV is still possible in traditional uh, vehicle or in this all two different architecture. But as you see, number of issues are too much. Managing them, or if you wanted to do auto update, you have to do for all these issues. It is based of resources, right? I'll tell you how basically, yeah. So first understand distributed ECU, what exactly distributed ECU is, yeah. So yeah, so this is only the architecture of distributed ECU. You would have a gateway over here, okay, and this is connected to here, yeah, and these are different CAN buses, okay, and these CAN buses basically have different number of nodes. And these nodes, basically, if we say no, the nodes, it is nothing but ECU is there, and these are distributed randomly into the bus. Yeah. So you may say, Nitesh, yes, if it is there, what is the problem? If I have to update, you explain it, number of ECUs are more, and that's basically you need the auto update for all these issues, which is complex. Yeah. Is this only reason, or do we have another reason? So understand, let me explain one issue. Okay, what exactly inside this issue is. Okay, so if you see, this issue would have on CPU, correct? It would have on memory, correct? It would have on software, basically main application, and also it must be delivered by some supplier A, for example. Similarly, other issue would have supplier B, the another one is a supplier coming from supplier C. These all things are problem. These all things is possible, right? So first thing is, if you want to have a capability of remotely update of these issues, first thing is you need to bring a mechanism for all these issues auto update, right? Only then it is possible, right? Otherwise, it is not possible. Do you not think it's auto explosion? Because for all these issues, you should have OTA update mechanism, right? And what if I tell you, you can have just only you in different architecture. If you manage OTA update for 4 or 5 or 10 issues, it is good enough to update entire, entire basically, vehicle. So because what happens in those architecture is like your application is basically residing on HPC, high performance compute, where all application would be running, and there you will update. You rarely update basically a general controller. I'll talk general controller because these are new term for you. So all right, so now you understand this has this all, you know basically one issue would have this many components. What is the problem? One is OTA explosion. That is something you have learned. Second is supplier A and supplier B and supplier C. There are different suppliers basically providing you the controller, right? And if you want a new feature, you need to coordinate with others also, right? Because if you are updating any of the features, you need to tell, okay, I am having previously, for example, in this issue, we have basically one one issue one, it is there, and it is receiving 5 different CAN messages from 4 different issues or 3 different issues, and it is sending 4 messages to 3 different issues, for example. Now if you increase or decrease, if you update the feature, and if the TX and RX signals are is changing, then you have to inform to all other basically those controller supplier who is basically providing, right? They should have this information. Otherwise, other issues on the bus, or if it is sending this issue to this issue and if it does not have this information, supplier, we will not implement this, you know, this signals receiving logic over here in this issue, and there is no use of those signal particular. Even though you update it here, it will not function as you have planned. So these are the second problem. Third important problem is data silos. What does it mean, data silos? For example, you have the vehicle running on the road, okay, and suddenly you see that there is a rain started and your vehicle is on the way, okay. Camera detects the rain, right? Now this data will be sent to what? It will send to first wiper issues. For example, this is wiper issues, then wiper issues, it will send to wiper issues. It will also send to headlamp, for example, headlamp issues, right? And also, if there is a basically rain it is happening, then for ADAS issues, this is also important because it has to know the environment conditions. Based on that, it will act on, applying a brake, all these things, based on environment condition, it will basically vary. So ADAS issues also need this information. So it will also give it to ADAS issue. For example, this is a ADAS issue, right? So what you see here is these are basically many CAN messages. Basically, only one CAN message is there that okay, this is the rain it is detected, but it is going into three different CAN buses or four different CAN buses. How basically issues are distributed? Do you not think that there are many issue interaction is happening for one signals, and these signals are distributed in different CAN network? CAN basically, CAN buses. So this is another problem basically, right? It can also be avoided by using different architecture, because here first of all lot of wirings are involved. Second is many redundant signals are flowing in different CAN buses, right? If all this application would be centralized into one single HPC, we can limit it, right? We can decrease the load of the vehicle, because this all signal, if you keep on sending, just I'm talking about 340, just single condition, single situation where it detected rain, there are thousand or more than thousands of situation would be there where, or basically thousand of condition would be where you would be your vehicle network would be quite busy with this all signals. Imagine how much load you are giving into this network, and then you will do the photo update. It is quite it's it if you have a number of pieces or less, you can do it photo update, but if you have too much, managing these all things would not be easy. It's really complicated. So that's the reason generally what happens is generally OEMs avoid this architecture for SDV, right? Yeah. So let's go to the next step. I'll just delete this part. Yeah. So next architecture is domain controller. Okay, what does mean of domain controller? Okay, so domain controller is something you just now seen that okay, there are issues and it was randomly distributed into the network. So now what it will be OEM has planned here is you might have there are issues belong to ADAS, right? There might be issues related to infotainment. There might be issues related to BCM. There might be issues related to powertrain, for example. Why don't you club all these issues? For example, if you have a DAS issue, you have A, B, right? You would have lane change assist, for example. You would have APA or a number of basically, issues. Can you not able to club it and just just group it into one and put into the bus? Uh, Similarly, infotainment can would be there. You you club all this issue, IPK, MMI, all this stuff, and then place into group it and place into one of the bus, for example. Just I'm giving you just example. BCM, you would have a sunroof, you would have a door, you would have a lighting or any issues. Just group it and place it to one of the buses. Similarly, powertrain, you just all these issues, whatever issue have, powertrain has, group it and put it into one bus. So what will happen is you will see, I'll explain you here in this diagram. So you will see these are the group issues and this is basically the issues for this particular group. For example, ADAS, this has all issues of ADAS. This is BCM, all issues of BCM. This is powertrain, all issues of powertrain. So what you see here is you will reduce significant amount of issues in domain controller unit, domain controller network architecture. Yeah. So how basically, okay, so one is you are reducing number of issues. Are this only benefit going into domain controller with respect to distributed ECU architecture? Answer is not only this. So basically, just I will give you one example. Okay. So imagine you from remote, if I have to do the parking in this vehicle who is basically having domain controller network architecture. What will happen if I do remotely update to this particular network in one of the issues? So again, there would be significant amount of reduction of issues, but it would have a still number of issues which I have to still manage for the OTA, right? Because it has again, because number of issues are there. Maybe it's not 100 plus, it might be 25. But yes, for all these 25 issues I need to do because all these applications, yeah, OS would be there, right? And all this basically all this layer of if it is AutoSAR issues, then all the stack would be there. All these things would be over here, right? So again, the same thing. If I have to do the OTA update, I need to have for all these issues. I need to do the rollback. I need to have for all these issues. Yeah. So 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 what exactly the as I was talking about one of the this was the one drawback. Basically, it is still it is reduced, but it in a significant amount, but it is not completely optimized. This is one issue. Second issue is if I have to remotely park and for example this is the issues basically for remote parking what all issues are required. Let's go in this way. For remote parking I need to send this data to whom? First would be ADAS should be knowing ADAS issue. For example, this is ADAS issue. ADAS issue should know that okay, remote parking request has came from remote, right? And second thing is this command should also go to the body control module. And also third should be powertrain, because powertrain should know that okay, now when you have to uh, you know stop the vehicle, and what how basically power would be, power should be as power distribution is happening. If the vehicles are stopped, it should basically basically open the contractor so that it should not draw further power. So powertrain should also know this all, right? So you see, again, we do not know who would be honor for this remote parking command, right? This all three would be equally responsible, and all three issues are distributed in three different buses. For example, if there are more buses, then obviously in more buses. So you still see that there are redundant signals are floating in this network, right? And if it has a central architecture where all the issues is running in one of the machine, HPC, high performance compute, then this can be avoided, right? This all redundant signal can be avoided and basically fixed to in single hardware. Basically nothing but your central, the one HPC basically, right? So, so these are different challenges when we are using distributed and domain controller. I'll come to centralized architecture, or maybe I'll explain you what is centralized architecture first, and then I'll ask you a question which many of the you people have already asked this question in my last post, and they have asked, they had the curiosity why you are going in this way. Yeah, so I will give you answer for those all. So let me explain you what exactly it has in the zonal architecture or centralized architecture. So basically, now you have seen, based on domain, they have grouped the controller and placed into the network in domain controller. This was basically the first step moving. The OEMs has basically decided in order to move into centralized or zonal architecture. So for this to understand, let me explain you this beautiful document from Texas Instrument. So they explained like, okay, the basically there are a vehicle, and in this vehicle network there would be high performance compute where all the application would be running. Okay, and there would be zonal issues and there would be edge issues. Okay, what does it mean is zonal issues or edge issues? So zonal issues is something like, as you see, these are the front zone, these are the rear zone. Furthermore, they can also basically give basically they can further divide into two different zones: front right, front left, rear right, rear left, right? But let's stick to just to understand in this picture, just I have only two: right zone, left zone, and basically there is a rear zone also. We have basically three different zone you can consider here: right, left, and rear zone. Okay, so right left is front zone, front right, front left, and rear zone it is there. And there is your HPC, just is something here. Yeah, so this is the architecture, right? And this all basically, right, this all the zone basically have a connection of Ethernet or CAN, or and also this all zonal controller would be connecting with the edge issues with the CAN or Ethernet, depends on how like what kind of applications issues you have. If it is required real time and you cannot compromise with latency, you will definitely go with the Ethernet. But if you need moderate moderate speed for this communications, then you can also go with the CAN. Lane would be very just for like not non-critical, non basically too much important, how to say, uh, lean R basically also will use lean R. Compared to this all, it is how to say, cheaper. And with lean basically like you generally control like how to say, sunroof or power windows, all these things you do with this, because you may not require too fast to act on within microsecond or millisecond. You can wait for 1 or 2 seconds, so you can go still with lane, for example. Okay, forget about this. I will not I have planned to discuss more on to offboard offboard components, but it is really important. That's the reason I am setting the context with onboard. So basically what exactly it has is like, this would be a general controller, and this controller would have very limited applications would be over here. Imagine you have one, for in my case traffic sign memory is there, right? Or you would have braking would be there, or you would have a wiper issues, for example. Now for this wiper issue you need a driver, right? You need also a fallback mechanism. What if your central compute is failed or somehow crashed? Your vehicle should not go on toss, and it should basically not should not behave randomly. For fallback scenario, you should have minimum applications residing over here at the journal controller, right? So basically what you see here is, so if I talk about this architecture in detail, so think of Your uh, how to say, think of this central compute is nothing but, you know, a smartphone OS that you have. Basically you have I have given an example in the beginning, or cloud application server. Yeah. So what exactly it will do, it will have, you know, how to say, it would have come, it is nothing but a vehicle application. It would be just act as a vehicle application platform. Example, if I'll give you, if you have to access vehicle, okay, how will you access the vehicle? You would have a key, you basically you manually you go and do it, but how basically you do it remotely? You can you can use phone as a key. You can have a digital key. Yeah, you can have basically from the remote you can unlock the car door, right? You can do that, right? This all application can be sitting over here and you can update it by any time, right? Similarly, if I have a DAS feature, I had talked AB in last video. For example, you have a DAS issues, and a DAS issues, most of the main application basically lane keeping, traffic sign recognition, parking assist, driver monitoring. All this application can sit over here, right? And minimum, for example, these are the DAS issue. So basically, for this, we would have a uh, we need basically, you know, to basic, and it is basically, for example, these DAS issues are sitting either right zone or left zone control, near the left zone. So basically this will be controlled by the left zone controller. In the fail-safe scenario, how basically it should act, this all things should be available in the zonal controller, but the limited application, main application will sit over here in the central compute. Yeah. So as I gave you example, so in what exactly in the central, now it's really clear, like in central compute you would have main application would be running, you can update most of the things would be updated in central compute, but also in the zonal control we also update it. For example, if we have to update the firmware, we have to update driver, yeah, we have to basically update some more logic for the fail safe. For that also we update this, you know, zonal controller. Yeah. So basically, if I give you one example of journal controller responsibility, you might be aware of IO control, right? For might have used IO control in traditional vehicle. For example, we have driver relay or control motor, reading the sensor, right? This all can basically responsibility will be given to journal issues. Yeah. So now you understand basically how basically this central or zonal architecture is, right? So now explain, let's go back to our original problem, how basically it would be easy if I have this architecture for auto update or remotely update or remote troubleshooting or rollback strategy, how it would be the best architecture compared to other what we have seen. Now you have seen, as I said, this would have a very minimum applications or logic would be sitting over here in this, right? And this controller is anyway it's coming from the end customer. Yes, we have to update this also, but imagine this all issue would be, as it has less logic, it is very rare chance to update. There would be chance to update these issues, but frequency would be very less. Yeah. And main application will sit over here. So now imagine if any of this application were requested remotely, you will just come into this block. You don't need to go into number of CAN buses. So will it not reduce the redundancy of this all signal? And basically it will also solve you basically load up your CPUs, because it's just one request is coming, right? So this way it will reduce your basically how to say uh, uh, CPU load. Basically also you don't need to have so many OTA update packages for all this stuff, because everything will be managed in single HP high performance compute. You can basically not only that, basically now imagine it's just a single word I said, like to update this 100 OTA in distributed architecture or domain controller architecture. Let understand here. Basically, you would have one application, one supplier. They are created applications on Linux environment. Okay, they had the Linux OS. On top of that, the application is running. Other comes and they have the Windows OS. On top of that, it is running. Imagine you are integrating all these things. Is there is there will there not be some issues if, because different OS application based applications are running together integrating. We need basically a lot of basically like a wrapper to write in order to talk to these issues, or as basically like if different issues are having a single operating system as a like as a base. On top of that it has to run, it would create a problem. But when it has central compute where you would have basically, you know, you just think of high performance computer, on top of that hypervisor, where you can have basically guest OS. And when you have a guest OS, what you can do it, you can enable basically different sort of OS. You can have Linux, or you can have basically Windows. Not only that, you can have once you basically dockerize your applications, you can a Linux container, or you can have a Windows container. They can run all this in the single box of HPC. Will it not solve your problem? Will it not ease your like update mechanism? So basically, that's the reason production grade HDB, you OEM basically opted central and zonal controller architecture, not other two. So that's the reason many people has highlighted, hey Nitesh, why you are using still a traditional architecture in order to update it, or whether it is possible to update it. So I, for that also I have created just just I created this. There is a typo over here. This is domain controller, this is distributed ECU architecture. So just what I'll do is I will have distributed ECU architecture. I'll add OTA. I'll do the cloud connectivity, and I not do remote diagnostic? Answer is yes, I very much I can do that. Similarly, if we have a domain controller ECU architecture, if I add OTA, will add cloud connectivity, can I not able to do remote diagnostic? Definitely I can do that. But if the number of issues are there, it would be easy to do. That basically I was explaining. I don't want to create basically, like it look like it's really complex things I am achieving. I wanted to make it simple. Yes, if FOTA or SOTA or FOTA can be updated in traditional vehicle architecture, why should not we do it? Because we have just to manage one or two issues. Why is to complicate stuff? So that's the reason I have, for the first phase 3 or first phase 4 until phase 5, I'll follow the same things. Because once I once this all concept is piloted, for me it would be easy to basically treat our TCU as HPC. On top of that, I will do the same way I will do the application update, right? Either I can containerize it, or same way I will use it. But to give you a real feel of STB or centralized architecture, I'll also play in the way like I'll make this issue basically I'll containerize the application, will run on TCU, and will show you the capability how basically real production get STB follow. Yeah. So what I mean to say is, my takeaway is SDB is not equal to zonal architecture. It's a highly, how to say, people do mistake and say SDB is equal to, it can only sit into general architecture, which is not true. You can have with the traditional issues. In fact, as I already told you, like in the beginning, OEMs had started, and for home project, it's good enough to start with traditional architecture and do this, to learn this all SDV concept. And this would be basically your approach also, because jumping into different, completely centralized architecture, it would be a bit complex, because you have to know how basically you apply containerize your application, then how basically you manage this container. Kubernetes comes in picture, and then once this all two things you have, then definitely you can do that. But just to set the context, just to make it simple, I'll recommend you to start with the traditional architecture approach, where you bring your OTA, you do the cloud connectivity, and then do the remote diagnostic or remote control, the same way what I have shown you. And I'll progress to the next step, basically next set of features. Yeah. So it would be the basically your path would be easy. You will understand more in detail in different architecture also, and you can basically, as you said, for the playground, you don't need to go with the full fledged all this everything applications running up and running and do that. Not required. Just to make, just to learn these all things, just start with the traditional or domain controller architecture base network, and then start doing your experiment for the STB. So yeah, so we have learned so far. Basically, also one important things I have put in the note is like Ethernet would be backbone for this, but doesn't mean like CAN would be obsolete, because you know you don't need to basically flash through Ethernet, because always to the through the basically using Ethernet, because it would be expensive. Also, if it is you are okay, only problem with the CAN is like it would be bit slow than the Ethernet. If you have application of 20 MB or 50 MB, it will work basically, generally 500 kps speed would be for CAN would be. And if you have big application, big binaries, it will take little bit more time. But if it is not critical application, or basically, depends on what kind of application it is, what kind of update you want to do. Based on that, you decide vehicle architecture, where the you wanted to update the application of firmware through CAN or Ethernet. It's totally depends on how basically you are architecting architecturing your basically, your vehicle network. So yeah, so what exactly now next is, so so far currently what I have shown in the demonstration in the video is I have able to do this CAN node creations. I have created as a gateway, I have local MQTT, I have created dashboard over here, and then I connected to AWS IT cloud, and also I was able to remotely manage it. But still there are few things I need to create, digital shadow, all this stuff. So I'll basically, I'll go for this all things, this all basically component I'll integrate in our project, and you will see sort of production grade SDV, where not all the issues would be there, just few issues, but the same way how SDV in a centralized approach, they are updating the issues or remotely basically, controlling the vehicle, that all we will learn it, right? So till then, please stay tuned with me for the basically for the next part. So basically next part I'll talk about phase, basically day 2. In day 2 basically I'll talk more about, physical CAN network setup. Lot of people has asked how basically you will set the physical CAN network. So and why it is required, or whether it can be basically, it would be optional, we can go with different approach. This all I'll talk in the next video. Till then, thanks for watching and happy learning. Thank you.